Hey everyone, welcome to Svelte Society NYC's third Svelte meetup, and the first one in 2020. Thank you all for coming here. So, this is the program for tonight. We're doing opening notes, 10-minute lightning talks, learn and hack time, show and tell, and at the end we might go to a nearby bar. So, opening notes. So first off, some announcements. We have new branding, thanks Vidin. He's over here. And we just updated our Twitter account and everything else with our new logo. And we also have new videos on Twitch. Yay!
Say hi to Twitch.
And to remind everybody, this is our code of conduct. We are dedicated to providing a harassment-free community that's inclusive, so we do not tolerate any harassment of community members in any form. And I think you guys agreed to this when you guys signed up on Down to Meet. And of course, call for speakers. For the last couple of meetups, it's been like Rich and Sean, and we really want the community to really like speak up more. So today I think we have our first community speaker, and we're gonna get started with our 10-minute lightning talks. So first off, that's for later. So first off, it's introduction to Svelte Stores.
Yay! Okay. Actually,
You need more time?
Yeah, no, I think I was gonna get mic'd up. I think I was gonna get mic'd up before
Oh, okay.
I do this. Let me just go get mic'd up.
Okay.
Rich, you want to say something?
So while Sean gets mic'd up.
All right, hello everyone. Thank you all for coming, and thank you so much to Wild, if you're still here, for making all this possible. Thank you to Sandy for organising the night. Thank you to the AV people in the back. And thank you, Vadim, for the new logo, which is fantastic. If I can get on internet here, there's just one thing that I want to share. If you haven't seen this, this is the annual State of JavaScript survey. It's a survey of all the different frameworks and build tools and this, that, and the other. And this was the first year that Svelte was one of the possible choices in the front-end framework section. And I want to show you the results because it's pretty cool if I can find it. Oops. Does anyone know how to use a web browser? I think it's 2019. Here we go. So the front-end frameworks, first time that Svelte has been included in this, and we are number 2 in satisfaction, right behind React. Which, given that we're a little bit new, we don't have dedicated dev tools yet, we don't have TypeScript integration, which people keep yelling at me for. I'm pretty pleased with how this small but perfectly formed community has acquitted itself in 2019. Obviously next year we're going to have to shoot for the top spot. But in the meantime, and on the interest tab, we are already at the top spot. Svelte is, by a little margin there, 3% of Vue.js, the most interesting framework to front-end developers currently, which is a nice little accolade to have. We are, however, right at the bottom of awareness, which is, I guess, where events like this come in. We also have the prediction award for the up-and-coming technology that might take over or not after what the State of JS people call an explosive debut. Now, there are a lot of reasons to take all of this with a pinch of salt. The State of JavaScript survey is mostly filled out by a very self-selected group of people, that is to say, people who hang around on Twitter and really, really care about this stuff. Is not at all representative of the majority of developers. But I think it's probably fair to say that it's a reasonable proxy for the early adopter crowd, the people who are going to be kind of shaping opinion over the next year or two. So I think this is a really encouraging sign for the future of Svelte. So hopefully 2020 is going to be a cool year, and hopefully you can all be part of it. Is Sean mic'd up yet?
Yeah.
Cool, over to Sean.
Okay, thank you. Wow, I can just speak and it works. Okay, I also need my slides, which I presume is here. It may not be, so I'm just gonna go to my own Twitter. And slides, there we go. Okay, cool. See, Google is wonderful. Thank you so much for Miles and for hosting, and for everyone for showing up. And I recently rewrote my one of my small helper apps. I have a Twitter overlay called Better Twitter. It doesn't do much right now. It's just a better search UI, but it at least doesn't tell you the trending news about Kim Kardashian when you search, which is a positive. I rewrote this from React to Svelte, and I, in the process, discovered how amazing stores are. So I figured I would just do a talk about Svelte Stores, and I think I can just sort of blast through it. So it's not a Svelte store as an e-commerce store. I was just like hunting for like a meme to start things off. But what stores are, based on the docs, it says a store is any object that allows reactive access to a value via a simple store contract. You can see the docs for that. But let's just talk about what that store contract is. It's actually super simple. Store contract means that your object should at least have one or two of these methods. The first method is subscribe. So when Svelte calls subscribe, and you give it a function, the function must be, and the subscribe function must be called with the store's current value. And you should also return an unsubscribe function to clean up any unsubscriptions, any subscriptions at the end. You can also optionally provide a set method, and the set method turns the store into a writable store, so you can actually set the value of the store inside it. What use is a store that you cannot set? We'll talk about that as well. Its job is to accept new values for stores and to call all active subscriber functions. So as long as you have it's like a pub sub type of model, and I'm sure everyone here knows. Okay, so let's write a store from scratch to really understand this model. Again, I really just love writing things from scratch just so you really understand it. And for people who are new to Svelte, this is how. This is the REPL, and it's a really good way to explain concepts. So I'm just going to create a new file called store.js, and I'm going to export like a time store, right? I'm just call this a time store, and then I'm going to, I'll have like a current value. Let's say, well, the current time, I guess. Let time equals to new date. I'll have you subscribe here. That takes a function, right? And then this is so back to the contract again. If in doubt, just kind of refer to the contract. When Svelte calls subscribe, the function must be called with the store's current value. So you should call the function with the store's current value. And that's about it. Let's actually see if we can import that and show it. So over here, I'm just going to say import. What did I call it? Time store? Yeah. Time store equal from store.js. And then I'm going to say time store.subscribe. And I need to expose it, so I'm just going to say that time. And time store.subscribe, and I'll pass it a function, so I'll just say x. Very, very terrible naming practices, but whatever. And then we can use Svelte's sort of setter thing to show this. Okay, so right, cool. We have a basic store implementation. This doesn't really do very much. So I'm also, but it just gives you an idea that it's an object. It has one method called subscribe. You pass it a function, and then you can expose it inside of your Svelte components. And then the other, let's actually make this do something interesting. I'm going to have to set interval. I hope I don't screw this up. And let's see, every interval I can set a new date, I guess. So the thing here is that I should be returning something. I'm setting this time every second or so, right? Because of the set interval. Hi, welcome. I'm calling this time because I'm setting this every second, but I'm not really broadcasting it to my component, right? So this is not really a complete store implementation. What I should do is keep track of number of subscribers. I'm going to use a set for this, which equals to new set. And so subscribers, I can just say like set.add function, and then whenever I call this and then, so whenever I set a new time, I can say subscribers for each. I have a function, and I can just call that function with time, the new value. Did I?
Extra ending.
Sorry?
You have an extra ending brace over there.
Here?
No, next line.
On line 5, you don't need line 5.
Do I just delete this?
Yeah. Yep.
Delete this? Oh, it works. Look, it's clicking. So yeah, that's the basic pub sub model, right? Like you have a bunch of subscribers, and then you like all the subscribe functions are called every time a store updates. You should also, for sort of memory leak reasons, you should also return a sort of cleanup operation. And this one is going to be a pretty simple, like subscribers remove function. And that's the whole idea. There's also a sort of memory leak over here, in the sense that if this component unmounts, we've called this subscribe function, and it's just going to keep subscribing and updating. So we actually technically should say something like onDestroy, which is a Svelte lifecycle, and then we should say something like let x or whatever y. It doesn't matter. Like, and then we should call the unsubscribe function over here. So that's technically the interpretation. That's technically what we should do. But really, all of this is sort of boilerplatey, and what Svelte lets us do is append a dollar syntax. So going back to my slides, you can either call .subscribe, or you can prefix stores with a dollar syntax. The dollar syntax auto unsubscribes for you, which helps prevent memory leaks. So this is pretty cool. So instead of all this like junk, I can just delete this, and then just put a dollar in front of the time store, and that was also going to work as well. This is kind of core to Svelte's philosophy of, like, you have syntax to deal with very, very common issues. Let's also make this a that's also, so this is kind of like, all right, there is some sort of core event source coming out to this store. But what if we want to set things from our user interface, right? Like we should have a writable store. So for no apparent reason at all, I'm going to call this writable. Actually, so one more thing before I go to that. So a store is an object that implements the contract. But actually, most stores that come from the official Svelte interface are actually like kind of store creators. They create stores. So you actually wrap this whole thing in like a function. So like a function create store, for example. And inside of it, you put all the junk that we just coded. Let's see. And then the real API looks something like create store const. Oh well, let. It's up to you whether you want to do const or let. And this is kind of a lot closer to the official Svelte store API. So let's actually make a writable store, and then I'm mostly done. So for no reason at all, I'm just going to call this writable, and I'm going to take an initial value. I will set that value to init val, and then get rid of all of this. Actually, whatever. Subscribers and set. Okay, so I call it with val. Yep. Okay, so a writable store actually implements a couple other methods. So let's actually look at what those are. I should probably have introduced them first before I before I show them to you. Never mind. I'll just explain. So the couple other methods that they should also implement is the set method. I did say that. So let's just call this new value. They were calling set new value. And then we're going to, so every time a new value comes in, we're going to set the value to new val. And then we're going to broadcast that, right? Subscribers dot, I hope everyone can see this, for each. And then I'll get a function back, and I'm just calling every function with the new value, right? So let's actually see how this works in practice. Writable, again, writable. So we created that store. It's undefined right now because they should actually already started off with 0. Let's change this to a button. On quick equals blah blah blah. I'm just giving an event handler over here. What do I call this? Store dot store equals to plus equals 1, for example. The auto formatting got me. Okay, cool. So what do we have here? We have implemented a writable store. This formatting looks terrible, but let me just clean it up a little bit. Okay, we have implemented a writable store. So again, I'm using the dollar syntax to assign instead of just read. This would have been a lot more annoying without the dollar syntax, which is very nice. Actually, it's not that much annoying. I just like store.set. And so this happens to be the official API of Writable, which is the official store. I mean, there's actually more stuff which we'll probably talk about right now. So for Writable stores, this actually works with setting values as well as binding values, a two-way binding syntax for Svelte stores, which is super cool. I mean, I have an example for how this is really good for forms. You can bind fields to like just an entire store, just like bind every single field to a form. And that's it, no code. Anyway, so the subscribe API is so flexible because you just have to have an object, right, that has a subscribe method, that it just works with RxJS out of the box. Ben Lesh, the maintainer of RxJS, was very impressed by this. But obviously, now that you know that there's no magic behind stores, it's no surprise. Svelte, yeah. This is an example from my code. Don't worry about the exact details of the code in there. But here I'm actually doing two-way binding and then accessing the store and indexing into it by key name. So imagine if you do a form, you can just have like every single field has a specific key name and you just put it onto an object in your store. And it's just two-way binding there. Very, very cool. No change handlers to write because it's already two-way binding, so that's very cool. And for me, this is nice contrast to React, where it's one-way data flow. You have to write all your manual change handlers, and you can kind of replicate store with context with state, as well as other fun stuff as well. So all of this is on that GitHub repo for that project, and I save versions of React versus Svelte. It's not like some sort of step change, sort of superior. I would say it's just like some things are easier to write, and for me especially, getting rid of the manual change handlers is very nice because I don't want to deal with those. So there are 3 kinds of official store APIs, and there's a 4th one which is kind of an orphan child. So there's Writable, which lets you set a subscribe, set an update, and also pass in an optional callback for unsubscribing. There's Readable, where you cannot have, so the first store that we wrote was a readable store. You can't really set it from the outside, but you can set internally. So here's actually how you do the set interval with the Readable API. So it's kind of like a read-only store. And a derived store calculates a store based on stores. All right, so if you want to do any sort of deriving logic, that's a really good way to place to put things. I actually highly recommend people to check out the source code. It's very readable, which actually gives you a lot of confidence about the store. So if you want to look at the Svelte runtime, you can just go to the Svelte source code. You can see animate easing internal motion in store. We're going to look at store here, and this is the entire source code for everything. It's only about 200 lines. So yeah, that's the, you're fully able to sort of dive in and write this from scratch if you need to, or just write your own custom implementations. In particular, notice that we don't actually have to set we don't actually have to set values right away, and we can set values more than once. And that's very relevant for what's about to come next. So let's talk about when to use stores for passing reactive values between multiple components. Reactive is important here because if you pass it by props or pass it by context, it's not really reactive. When it updates, it's not going to immediately re-render. But you can actually pass a store into a context to do that. When else to use stores, you can use it to wrap things that are naturally like event sources from outside of your app, like your mouse position, browser APIs, and sockets. I also think a state machine would be pretty cool. Like when you set things, it just processes through a state machine, and then the final value is returned. And finally, the one other official store API is Svelte Motion for easy tweening and spring animation. So let's talk about that. This is super cool. So Svelte Motion are a kind of writable store. So writable stores implement the subscribe method, they implement the set method, right? So there are two ways to do animation with this thing. So you can tween, which is like you have A, and you have your initial value, your new value, and you want all the things in between, right? You want to update it smoothly over there. Or spring, where you have sort of physics-based animations for your values. So actually, let's actually take a quick look at the tweened tutorial. So this is how like a normal state update would be, right? Like I want to set things to 25%. I want to set things to 50%. I want to set things to 75%. So the nice thing about tween being the exact replica of the writable API is I can just switch this to the tweened from Svelte Motion. And so now I have a different type of store, and it just animates nicely with the values interpolated in between, which is super, super cool. You can also, one of the other things I really enjoy about this is being able to customize the interpolation functions. So Svelte tween interpolation function, let's actually just stick it in here. So when would you want to customize the interpolation function is when you have something there's just not a simple value. So here I'm going to interpolate between RGB values. I'm stress testing you're a REPL right now. Ignore. Okay, cool. So I have just strings: RGB red, RGB blue, RGB gray, and being able to tween to interpolate between them from a custom interpolation function is very cool, right? Treating them as single values and you're just interpolating them. So very, very customizable, and it's all from this underlying store concept, which is really cool. Okay, and Spring is kind of the other child. So I'm just going to show you how to do this. So you have some sort of physics-based animations to this. And it has a very nice sort of natural-based easing. Although Svelte itself actually ships with a bunch of easing functions, which are really useful as well. Okay, so that's it. What can we learn from stores that's reflective of Svelte overall? Svelte embraces mutability, and you can see how we use that inside of stores. Svelte also tries to offer more first-party APIs instead of a very thin API surface area. Offers sugar syntax for common use cases. A simple contract that you can keep in your head, as well as a bundler which only includes what you import, right? Like there's a whole bunch of first-party stores, but if you only use one of the stores, then it's going to only include that in your application. So very, very core to this Svelte philosophy in general. So I like that about stores. Yeah, now you know Svelte Stores. Thank you. If anyone has questions, I can quickly answer. If not, I can just kind of move on. Yeah? All right, cool. All right, on to Jeff.
It's Jeff.
Yay.
Hey everybody.
Oh, you made that.
I am. Yeah, so it's awesome. Thank you, Sean.
Thank you.
I'm just gonna pull this set up here. Alright.
dropping in and out of the slides. Just not really that much by way of slides. But anyway, so my name's Jeff. I'm on the Web Developer Relations team here at Google. Sometimes I have to build web applications. I'm not really great at building web applications. I found myself needing to build a web app a few months ago leading up to like Chrome Dev Summit, which is our big event, and sometimes we launch new features in Chrome and we want to show people how to actually use them. So it's like, I'm gonna build a web app. And it seemed like a great opportunity to use Svelte. So I am by no means somebody qualified to get up here and talk about Svelte in any detail, but I thought I would share what I built and maybe just like run through the code a little bit and maybe share a couple of cool question mark things. One of the things I do quite a bit though is progressive web app tooling and kind of things with service workers, and maybe I'll spend a little bit more time talking about that bit within Svelte. So that's the idea. This is what I built. It's only runnable on Android Chrome, unfortunately, for reasons of the actual APIs that it's directly using. But if you happen to have an Android device and you happen to have Chrome installed, you can go there. It's scrapbook-pwa.web.app. And I'm just going to drop out of this right now and go to this Android emulator and show folks what it looks like and see how the Android emulator dealt with the change in resolution. Let me just restart that. Just so folks have some idea what I'm talking about. Okay, hopefully that's kind of visible on the screen. So basic idea of, well, first of all, a little bit behind progressive web apps, because maybe not everybody knows what that means. It's the idea of building a standard web app and then having some additional capabilities, usually powered by technology called service workers. One of the things in particular is like being able to install them and having hopefully all the data you need cached and available offline. I'm going to go here and you will see this little add scrapbook PWA to home screen prompt at the bottom over there. That's kind of, as a user who happens to navigate to a random URL, you're hinted that, hey, there's actually something that you can install and that's going to behave like an application. Normally that's not super important. You could normally do stuff with progressive web apps just from within the browser, but for this specific technology that I was trying to demo for this, which is integration with Android's native sharing sheets, you do need to go through the install flow, and that will actually like generate a web APK is what we call for it. So it'll behave like an Android app at this point, and that's important for this. Fortunately, it seems to work fine in the emulator. I did not fully test this in the emulator, so hopefully it works. Otherwise, I might just hold up my phone screen. But let's see. So, okay, so it's added my scrapbook PWA to the home screen. You see here, you have a nice little icon and everything. And I just want to show you what it does before I talk about the code. So, open this up. Looks like an app at this point. It's all built in Svelte. Doesn't do much right now. Basically, I'm not sure how well folks are going to be able to see the screen, but it's like you don't have any saved images. The idea is you can go to other applications in Android. You can then share to it, and then you can also share from it. So it's kind of like a temporary scrapbook or like, I don't know, temporary clipboard type thing. It does not store anything in cloud or anything like that. Everything's stored locally in cache storage. And it's pretty useful. And this is like a test account that I have not used in many, many years. We have some nice pictures from Prospect Park in 2007 and like when my wife made biscotti in 2006. So that's what's available. Let's get a biscotti picture. I'm gonna share that. Sure. Okay, and hopefully, yes. So this is just the standard Android share interface. By virtue of having gone through that install flow, my scrapbook PWA appears there, and I select it, and you see that it has now been shared to my web app. And from the web app, I could then, I don't know, I think I have a view over here. I'm not really good at web app design, so that's what it looks like that. I also have a share, so this test's going the other direction. There's also, you know, APIs as part of the web platform for doing sharing out. What we just saw previously was known as the share target API. You have a web app that acts as a target for sharing. This is like just the web share API level 2. which lets you share outward to other things. And I don't think I have very much installed here. I guess if I chose photos, I'll just make another copy. Yeah, so this will do uploaded photos. So it's all just nicely integrated with the Android operating system. Hopefully other operating systems in the future, if other browser vendors choose to implement that. So anyway, okay. It's, what you're looking at though is a pretty basic single page app. I will dive into the code in a little bit and then also talk a little bit about the service worker part of it, because that was actually kind of cool for handling the incoming sharing of images. I don't think I have anything too meaningful here. Yeah, those are just kind of notes myself. So the code for all this is available in the samples repo that we have. I'll share it out some point later, or if you go to the web app and to the help screen, it'll take you here, so you should be able to get to it. But yeah, I just wanted to talk about a few things in particular. First of all, I really like Svelte, so thank you, Rich, and everybody who worked on the docs in particular. It was a very, very easy experience getting started, in particular because of all the interactive docs and examples there. So I think if you have been thinking about trying to use Svelte and haven't actually committed to going forward with it yet, like start with the docs. They're great. And I think that kind of this is the structure I came up with. I'm using what may or may not be like the official way of doing single page app routing. It's like using Svelte SPA router, which worked pretty nicely. And then I decided I was going to break all my different kind of like pages into different routes and expose some metadata on those routes. Kind of the interesting thing is that probably is pretty standard for building SPA. Kind of the interesting thing in this particular case is I had to share some of that data between both my kind of actual web application, but then also the code in the service worker, which needs to know about how to handle incoming share requests and then how to route basically after you do the share. I don't know if you remember from the demo, but it took you to the page that actually had the new thing that you shared. So that's some metadata that we wanted to reuse. And I thought that, in particular, I've been doing a lot of stuff with ES modules, and the fact that everything in Svelte is an ES module made it pretty easy to share all that. I don't think there's anything super interesting up here, and this is just my attempt at coming up with an app structure. One of the things that, I think these are all pretty much the same. One of the things I like doing is just keeping everything together in one place. It's another thing with Svelte that probably folks who have used it in the past have been pretty happy about, is just having one file that has your code, has your HTML, has your CSS. So it's very nice keeping this all together. And this was a really nice little piece of syntactic sugar that Svelte offered, which was native support for promises and things that are async and a returning promise. So I have a lot of interactions with cache storage API, which is a standard way of saving HTTP response data in progressive web apps. That all is promise based, and all you need to do is put this pound await, and you get direct access to the resolved promise once async operations actually completed. So it's really nice not having to write any code to structure and natively do then or anything like that. It's just say, okay, don't do anything until this promise is resolved, and then assign the value to this variable, and it all just happens. So that was really nice. All the other routes kind of work the same way. And components, kind of just little bits and pieces, not super interesting there. The parts that are probably a little bit more interesting though, in particular, let me just talk about the service worker implementation. So the service worker is, for those who've never played around with progressive web apps before, I could definitely talk a lot more about this, so grab me after, but just really briefly, it's the idea of basically JavaScript that sits in between your web browser and the network, and it can intercept network requests, both outgoing, which is normally what you do, but also kind of incoming, which is what we're doing in the case of the web share API. So the way the web share API web share target API is defined, you basically get a incoming HTTP post request to your web application, or basically to whatever URL that you want, but in this particular case, it's to the URL of my web application. And you get to say, over here, what you, as part of the manifest for your progressive web app, you get to say, hey, use this particular URL, and use post, and multi-part form data, and that sort of thing. And then pretty much the way you're always going to handle this, I think, is with the service worker. I don't know if anybody would do this by posting directly to a web server. So I think the expectation is that you're going to use the service worker. But the service worker here is listening for an incoming post event, and there's actually just really nice web platform primitives for parsing multi-part form data automatically and for like dealing with the bodies of these incoming web requests pretty directly. So the amount of code that I had to put in my service worker was pretty minimal. And the other thing I'm doing is using a set of libraries that I work on as part of my main job called Workbox for handling things like different caching strategies and going to the cache first and then the network and pre-caching a bunch of stuff. So this is an example of using those within a Svelte app as well. But the main things I was doing, so here's what I was talking about a little bit before, where I'm sharing data about routing between my kind of individual component that's being used for doing Svelte SBA routes stuff on the web app, and I get the same data pulling into the service worker because it's all ES modules, and I can make use of that later on. I'm going to skip this part about the content. Sorry, this is the content indexing API. I'm going to just skip that for a bit. This is the part that actually handles that incoming post request. So it'll try to post a message saying, hey, it's saving media locally. And then actually just getting the body of the post request is super straightforward. It's these, well, not all these lines, but some of these lines are pretty much just reading the body. And once I have the body, you could then write it out to cache storage via this cache output and create the response that uses the incoming body. And here's the part that's actually kind of sharing some of the routing data. I'm just figuring out, hey, what kind of media is being shared. So it supports images, videos, and audio. And depending upon the first file, because we might also share multiple images in one go. Whatever the first one is, I try to find the appropriate routes, and then I return like an HTTP 303 response to go to the page within the Svelte app. So that all worked pretty straightforward for me, at least. Well, no, let me take that back. That was kind of a bit of a hassle to come up with. So I don't want to minimize that, but I was happy with the final result. And just the rest of this is a little bit of kind of boilerplate for doing things like honoring range requests, because the browser will add range headers when it's playing back cached video or cached audio, and we have plugins in Workbox to take care of that. And then dealing with some pre-caching of assets generated by Svelte. And yeah, here's just registering that share target for a post, and here's registering something to handle the cache media. So that's the service worker. The part that's not the service worker is this part, and this is kind of boilerplate. It's basically, I went with an approach of registering my service worker when the page loads, but then also just listening for visibility change events to check for an update. I think one of the things that people sometimes don't realize with a single page app is that if you have things that are cached very aggressively by a service worker, you will not necessarily get an update when you click on links within the app, because it's only during real navigation when that happens. So I wanted to account for that by forcibly checking to see if there's an update for any of my stuff that's pre-cached, and then basically calling reload if it does. I'm cheating a lot, and I think if I knew more about Svelte, kind of like in the area of things I would improve and will hopefully improve as I learn more about Svelte. I think listening to some, what I'm assuming exists in terms of native Svelte events for like figuring out if maybe visibility has changed or dealing with some native transitions and like triggering these updates during those instead of maybe when the browsers document the visibility state changes. That might be one thing. I'm also cheating quite a bit by just forcibly reloading my page whenever I know that I'm making changes to the cache storage rather than doing some excellent things related to store that Sean was just talking about, where I can probably have a way of subscribing to changes in something that exposes the cache storage and then updating things on the fly. The kind of wrinkle with this particular application is because it only really works if you are launching it from the add to home screen flow. You're only going to have one instance of it running ever, pretty much. So I wasn't quite as worried about like synchronizing state or like having another instance modifying the cache storage and leaving me in a consistent state or anything like that. So that shapes some of my decisions, as well as like laziness and not being super familiar with Svelte. But yeah, that's pretty much what I wanted to talk about. I am happy to go into detail, later on about anything specifically like progressive web API, because that I feel a little bit more qualified to talk about. But I would recommend folks who haven't tried out Svelte yet for little projects, for bigger projects, give it a try, because it is super fun to use. And yeah, that URL again over here. If you want to check out that, it's scrapbook PWA.web. So cool. Thanks everybody.
Okay, so I'm going to be talking about tracking changes with Bitmasks, which is a new implementation detail in the newer versions of Svelte. Not a new feature, doesn't actually affect how you write Svelte components at all, or the things that you can do. It's just some tuning under the hood that makes things a little bit smaller and a little bit faster. This image is a screenshot from Eyes Wide Shut, the Kubrick film, which is a really fucked up film with face masks, and tonight I'm going to be showing you some fucked up code with Bitmasks. Also, if you've seen the film, a lot of the characters do like to show their bits, so it's appropriate. So the point of Svelte, in one sense, I mean there's lots of points of Svelte, but the point of Svelte is to generate optimized code paths for different state change scenarios, and what I mean by that is that if you have a component like this with 3 values, all of which can change, we can change A, we can change B, we can change C. It doesn't make sense if when I change A, we need to update the DOM for the B and the C parts. So the code that it generates or generated looks a little bit like this. We have this object called change, and it has Boolean properties corresponding to each of the variables inside the component. And then there's this other thing called context, which contains the actual values. And so we'll do if change.a, that means if the value of A has changed since the last update, then we will change the value of that text node by directly manipulating the DOM. And this is all well and good, it works. It's pretty efficient, it's like the reason that Svelte is relatively performant in most situations. But if we start to do things like this instead, and then replace sort of our single character variables with those, then you'll start to notice that the generated code gets a little bit more unwieldy. And I'll show you what that looks like. So down here we've got change.firstNumber, ctx.firstNumber, and so on. And the reason that's bad is because when you minify that code, those property names will still be written, because property names don't get mangled unless you're using closure compiler on like the advanced setting or something, and even then it doesn't always work. So that's not great. And also down here at the bottom, where we're doing the setup work, we're creating these click handlers to handle the events, and then we're creating this object that contains all of those things named. So if I just copy all of that and paste it into the terminal and then minify it with the module setting, then you can see that we've got click handler referenced here, and second number over here, and third number over here. And it's not great. So, can we do better?
Yes.
Project names are mangled, must be repeated several times in the generated code. That changed object, the dirty object, which is tracking what's changed from the between renders, that's going to be recreated after each component updates. So that means that the garbage collector has a bit of extra work to do. Not a lot, but every little helps. And actually doing the object property lookups isn't a free operation. Like, there's a very minuscule cost there, but these things mount up. So a while back, we started thinking about using Bitmasks, which are a scary sounding technique for combining multiple Boolean values into one. For those of you who've got like a computer science background, this might feel a little bit CS 101. I don't, so this is kind of new and exciting to me, and I want to share it. What a bitmask looks like is this. I wanted to do this within the PowerPoint slide, but I figured it's actually easy to just generate this in a REPL, so we can see it here. So the first row of numbers here are my 5 options, call them A, B, C, D, and E. And then the second row contains, so the first row, we're going to call that the bit field, and the second row we're going to call that the bit mask. And the way that it works is you assign a number to each of the options, doubling it by 2 each time. So A is 1, B is 2, C is 4, D is 8, and E is 16. And then the bit field is just the collection of all of those added up. So if we have like A and C, the bit field will be 5, and D, 13, and so on. And the bit mask, if we wanted to do an operation on that, say we wanted to add B to the mix, we could just add 2 to make it 15, but then if B was already set, we'd be making it 17, and that would be wrong. So we can use the bitwise operators, which are these characters. You've seen the binary operators when you have like if A double and ampersand B, that means if A is true and B is true, and you've probably seen the corresponding one with the pipes, which is if A is true or B is true. These are kind of similar, except they operate on integers at the level of the binary bits that make up those numbers. So if we use the pipe bitwise operator, then you can see, in fact, maybe if I make this tiny bit smaller so that we can see the whole thing and get rid of the enter full screen. There we go, a bit more space, maybe. So the bit field pipe bit mask is 15. That's all of A, B, C, and D. So for the next operation, by the next time we come around, because we've applied that operation, we'll have all of these things set. And this is really useful because you can check whether an individual option in that bit field is set by comparing it with your bit mask. So if you have a bit mask that contains the 4 for the option C, then you can see on this first row right here that lights up because it's taking all of the bits that make up that binary number and it's seeing which ones line up, which ones are both 1, and then combining them. And so you can start to see how you could use this to determine if certain values have changed inside your component. The last bitwise operator is the little hat sign there. That is the exclusive OR, which is all of the things where only one of them is 1 and all the others are 0. So here, A and B are both true in the top case, so these are both 1, but because both of them are C, that is a 0. So, and I haven't actually had to do a whole lot of setup to get this to work because I'm using some other bitwise operators. This double left arrow here takes the binary numbers and it left shifts them by 1. So your 1 becomes a 2, your 2 becomes a 4, your 4 becomes an 8. And so if you do 1 left shift by 0, you get 1. If you do 1 left shift by 1, you get 2. 1 left shift by 2, you get 4. And I can actually show you that here. So this is how you write a binary number. You prefix it with 0b in JavaScript. So that is 2, for example. 2 shifted to the left by 1 is 4. If you have a number like 10 and shift it by 3, you'll get 80. So this is like a really fast and efficient way to do a very limited subset of arithmetic operations. And we're literally just querying the bit field itself using the bitmask that is generated from the index within the loop. So we're not like tracking separately whether A is true and B is true and C is true and so on. It's all being done using the bitwise operators. So that was kind of a confusing and quick introduction to thinking in bitwise operators. How does it apply to Svelte? Well, if I can go to my saved apps, I can show you the thing that we had before, but this time it's using the most recent version of Svelte. And if we look at that update code now, it's comparing the dirty value against the number 1 for the first number, and against the number 2 for the second number, against the number 4 for the third number because it's 1, 2, 4, 8 and so on. And then here we've got an expression that contains all 3, and before we would have had to do change dot the first number or change dot the second number or change dot the third number, but now we can just do dirty and 7, and that is the expression that determines whether or not the contents of that paragraph tag will need to be updated on the next update. And the really nice thing about this is if we take hold of that and run it through here, that's 1087 bytes. If we go back to the previous version, before we had this feature, do the same thing again. 1548 bytes. So you see we made a pretty substantial saving, admittedly in a somewhat contrived example, but you can see how this will result in smaller applications. And because the memory usage of this is reduced, because it's just an integer, it's not an object with a bunch of properties, and because there's less work for the garbage collector to do, in theory this is going to make your applications faster as well as smaller. You can also do stuff like this. This is a tweet that I just happened to see today, which is absolutely nutso, but whether or not you will ever find a use for this is debatable, but it's nice to know that you can. There is a catch, however. In JavaScript, bitwise operators work on 32-bit signed integers, and one of those bits determines the sign, which is whether it's a positive number or a negative number. So what that means is that we can only represent 31 values with a bitmask, and most components will not have more than 31 values that you can change, but some might. And so we need to have an array of bitmasks instead. And so that's why if you look at that code, go back to the current version, you'll see that we're actually destructuring the dirty array to get the number. Because in this case we only have 3, so we don't need to use the array, so we're destructuring it to get the underlying number instead, if that makes sense. Okay, so I haven't found a ton of uses for these techniques, but when you do come across them, it's pretty fun. This is a nice little example. I often find myself manipulating colors in various ways. like trying to parse color strings or turn a collection of color components into a color string. And this is quite a nice way to do it. Let's say you've got a hex value representing a color, something like this, right? So F70E00, that is the hex color that you might use in your CSS. That corresponds to a number which, when written out in hexadecimal, is basically the same. You prefix it with 0x to write in hexadecimal in JavaScript, and then it's just the same thing, F70E00. Or you can represent it in base 2, and you can see that there's 24 different bits that make up a color, 3 bytes. And then in base 10, it's a number which doesn't really correspond in any meaningful way to the number that is displayed on screen. And so we can take that hex value and remove the pound sign at the beginning and parse it into a JavaScript number using parsing and passing the second argument, which is the radix. That determines the base of the number system that you're dealing with. And then once you've got that number, you can split out the different components of that color. The red is what happens if you apply the RGB bit field and this bit mask, 0x FF0000, means only keep the red values and discard everything else, and then you right shift it 16 bits so that it becomes a number between 0 and 255. And then you do the same with green, except this time you're only preserving the 8 bits in the middle of that 24-bit string, and then you're shifting it 8 bits to the right. And then the same for blue, except this time you don't need to bit shift it at all. And so you can see, as I'm waggling my mice around here, the components updating to show how that color is broken down. And that's just using a regular old progress element. And actually, if I switch it over to this view, then you can see that the sliders in my color input correspond perfectly to the components in the progress bar. So that's a fun thing to do if you ever need to deal with colors. Also, recently, someone raised this PR on a library that I maintain called Magic String, which is used inside Rollup, Module Bundler. It's also used inside Svelte. And there was a bit of a problem with Magic String because it maintains all of the locations of the source code that you pass into it so that it can then later generate a source map. That's kind of the whole point of what this library does. But it's super memory intensive because it was storing all that information on a giant object, and it was causing people's browsers to crash, or causing people's node processes to crash rather. And so someone came along and said, what if we used a bit set instead? And a 200 kilobyte JavaScript code file had a source map locations object of 980 kilobytes. After this PR, it's 36 kilobytes. An almost 2 order of magnitude improvement by using this technique. So it can be useful if you find those rare cases. There's my slide. Get your bits out.
Check time. So we're gonna take a break, and when we come back, it'll be learn and act time until 8:45. So yeah.
Well, so I mean, I realized that like the main hack time is basically the same as a break. Typically, we're in the same room, so we don't like leave to a separate room or something. So we might as well show the learning hack time slide. Okay, so this is so you know for those who are new to this meetup, we kind of have two sections. Right? First is a bunch of talks to get you motivated. Second is for you to get your hands dirty and work on something and try something out. So for total beginners, I recommend going to svelte.dev/tutorial, and that will guide you through the basic APIs. For people a little bit more advanced, take a look at Sapper, which is
the server-side rendering, static rendering framework that comes with that is helpful for building production sites. What is that?
Very attention, please.
Yes.
Very attention, please.
Uh,
We will be conducting a test of the building's fire alarm system. Please disregard all signals, tones, or alarms you may hear or see.
it's
I
very hard to
repeat,
ignore you.
we will be conducting a test of the building's fire alarm system. Please disregard any signals, tones, or alarms you may hear or see. This is only a test. Thank you.
Svelte is off, but I didn't know it was that hot. And then the third one is all the third-party community libraries. We're trying to aggregate all of them here. So Svelte community/code is where it is, and you can see all the links on Svelte. And also like my demo, Jeff's demo, Rich's demo. You can also just try it out. Like do something you haven't done before. That's super helpful. So I think oh, and by the way, if everyone hasn't connected to Wi-Fi here, it's Google Guest Wi-Fi and no password. So that's super helpful for just break out, form small groups, and then we have a show and tell at 7:45. And also the reason I have this box here, is I have a Svelte sticker, so I'm going to be putting it. But yeah, that's it. Great. All right.